So far, we have used derivatives to study behavior of functions and find horizontal tangent lines. Now, we are going to look at another application of derivatives in motion. In particular, we will connect derivatives with velocity and acceleration. Example 8. A car driving along a freeway with traffic has traveled s of t equals t to the third minus 6t squared plus 90 meters in t seconds. Here, s of t represents the position function. Remember from calculus that the derivative of position gives us velocity, and the derivative of velocity gives us acceleration. Question A. Determine the time in seconds when the velocity of the car is 0. To find the velocity is 0, we first need to find the velocity function. Velocity is the derivative of the position function. So we take the derivative of s of t. Using the power rule, the derivative of t to the third power is 3t squared. The derivative of 6t squared is 12t. The derivative of 90 is 9. So the velocity function is 3t squared minus 12t plus 9. Now, set the velocity equal to 0 to find when the velocity is 0. Next, we need to solve this equation. This is quadratic equation, so we can either factor or use quadratic formula. Look at 3t squared minus 12t plus 9. These three terms has 3 as a common factor, so we'll factor 3 out. So we have 3 times t squared minus 4t plus 3 equals 0. Now we need to factor this quadratic expression. T squared minus 4t plus 3 factors to t minus 1 times t minus 3. Now we let t minus 1 equals 0 and t minus 3 equals 0 to solve for t. From this equation, we plus 1 to both sides, so we have t equals 1. From this equation, we add 3 to both sides, so we have t equals 3. So the velocity of the car is 0 at 1 second and 3 seconds. Question B. Determine the acceleration of the car when the velocity of the car is 0. Now we want to find the acceleration of the car. Remember that acceleration is the derivative of velocity. So step 1, we find the acceleration function. A of t is the acceleration function, and A of t is equal to the derivative of velocity. And from part A, we found the velocity function is 3t squared minus 12t plus 9. Now we need to take the derivative of this function to find the acceleration. The derivative of 3t squared is 6t. The derivative of 12t is 12. And the derivative of 9 is 0. So v prime is 6t minus 12 plus 0, which is 6t minus 12. So the acceleration function equals 6t minus 12. Now, we want to evaluate the acceleration when the velocity of the car is 0. Remember from part A, we found that the velocity of the car is 0 when t equals 1 and when t equals 3. So step 2, we want to evaluate the acceleration when t equals 1 and t equals 3. To find the acceleration of the car when t equals 1, we plug 1 into the acceleration function. So we have 8 of 1 equals 6 times 1 minus 12. 6 times 1 is 6, and 6 minus 12 is negative 6. To find the acceleration when t equals 3, we plug 3 into the acceleration function. So we have 8 of 3 equals 6 times 3 minus 12. 6 times 3 is 18, and 18 minus 12 is 6. So when the velocity is 0, the acceleration is negative 6 at t equals 1 and 6 at t equals 3. This example also shows an important application of derivatives in motion. The first derivative of position gives the velocity, and the second derivative of position gives the acceleration.